Today's lesson is over scientific notation. Scientific notation is when a number is written as the product of a factor and an integer power of 10. The factor must be greater than or equal to 1 and less than 10. So what that's saying is the first number in your scientific notation should be between the number of 1 and 10. Okay? Anytime you use scientific notation, you're going to multiply by a 10 raised to a specific power. So, for instance, they have this number here, 425 million. 425 million you want your first number to be between the numbers of 1 and 10. So I start at the very beginning of my number and I go all the way until I find a number that's not 0. The first one I come to is 4. And I can put a decimal after that. And now that number lives between 1 and 10. So I'm going to rewrite that number as 4.25. I always multiply by 10 in scientific notation. And then I need to determine how many times I need to move a decimal from here to turn it into this number. And all I have to do is count it out. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to raise this to the 8th power. And that is how I can represent this number in scientific notation. A lot of times it makes really small numbers easier to compare and really big numbers easier to compare just by making sure that we have it in a ones place here, and then we're multiplying it by an exponent. We can compare those exponents first. Okay? Anytime you're trying to make a number smaller to be in between 0 and 1, like your decimal numbers, your exponent will be negative. Because just like we talked about in the last lesson, the last 2 lessons, anytime you multiply 2 numbers together, when you continuously multiply over and over and over and over again, you have a positive exponent. When you continue to divide over and over and over and over again, you have a negative exponent. So when I'm dividing things from a whole number into a decimal, I need to be using negative exponents. So we have these 2 points right here. Use the rules to express a number in scientific notation. If a number is greater than or equal to 1, the power of 10 is positive. If the number is between 0 and 1, the power of 10 is negative. Now this has nothing to do with negative numbers right now. We're only talking about a negative exponent. Does not mean it is a negative number. It just means it's a decimal. Powers of 10, multiplying a factor by a positive power of 10 moves the decimal point to the right. Multiplying by a negative moves it to the left. So for instance, since I took this and moved it in this direction, we were moving to the right, so my exponent needs to be positive. I'll show you an example of a negative here in just a second. Some examples here. Number 1 is 5 and 34/100 times 10 to the 4th power. Just rewrite that out. 5 and 34/100 times 10 to the 4th power. To show your work, you copy the first term, and then you move that decimal the number of times the exponent shows and in the direction that it tells you. So since it's positive 4, you're going to move it to the right 4 times. So from here it goes 1, 2, 3, 4, and you're just going to fill in with zeros. So your new answer is 53,400. The next example was 3.27 or 3 and 27/100 times 10 to the negative 3rd power. Since your exponent is negative, we're going to be moving to the left 3 times. So I'm just going to copy down my first factor and move that decimal 1, 2, 3 places to the left, and once again fill in the zeros. So my final answer would be 0.00327. Okay? A lot of times your your book and stuff will demonstrate it, adding an extra 0 out in front. You're more than welcome to do that, but I will not count off if you don't. So for example, on these examples, 7.42 times 10 to the positive fifth, I'm going to move that decimal 5 places to the right. Letter B says 6 1/10 times 10 to the negative second power, so I'm going to move it 2 to the left, making it a decimal. You should be able to tell what your number should be like based off of their exponents. Okay? You also are going to be required to go backwards and go into turning a standard number into scientific form. One other key thing I want to tell you real quick is you may still end up with a decimal in your answer if you have a positive exponent. Talked about this in class. There may be times where you have the number 4.3768 times 10 to the third power. You come back and rewrite that decimal just the way it looks to begin. Since it's a positive 3, I'm moving it 1, 2, 3 places to the right. Well, there's still going to be a decimal in my answer. My final answer would be 4,376 and 8/10. Okay? So just because it's a positive doesn't mean that you won't have a decimal somewhere in your answer. That could be a possibility, but your value is going to be greater than 1. Okay? So this example here, we have the number 3,725,000, and I want to turn it into, or express it using scientific notation. To show my work, I'm just going to come into that number, starting at the beginning and finding the first number that's not a 0, well, it's right here. And that's where I'm going to place my decimal. So when I write my answer, I have 3.725. When there's only zeros left, I do not have to add those back in. Zeros at the end of a number do not change its value. In scientific notation, I always multiply by the power of 10. And then I just count. I need to move it to the right. So my decimal's going to, or my exponent's going to be positive. And I'm moving that decimal 1, 2, 3, 4, 5, 6 places. So my exponent is a 6. On the next example, we have a decimal here. It's 0.000316. Using those same rules, I'm going to come all the way until I find a number that's not 0. The first number that I find that is not a 0 is a 3. So that's where my decimal will belong. My first factor will be 3.16. In scientific notation, I always multiply by 10. Well, now for me to get this new decimal back where it belongs, I have to move it to the left, which means my exponent is going to be negative. And it's going to move back 1, 2, 3, 4 times to get back where it belongs. So my exponent is a negative 4. One reason we like to write things in scientific notation is it makes it so much easier to compare numbers, especially when you start talking about numbers in the millions and billions and 100 millions and 10 millions and things of that nature. It's a lot easier to compare numbers when they're all brought down to the same value. So let's look on the next page in your book. This got it problem, you have one worked out up here for you. But the got it problem, some of the top U.S. cities visited by overseas travelers are shown in the table. Order the cities according to the number of visitors from least to greatest. There's a couple of things that I want you to keep in mind. This question is asking you to order the cities. So your answer should be cities. You should have words here, not numbers. Make sure that after you do your math, you go back and double check that your answer is actually answering the question. Because some of you may go through and do all of the correct math, but then start writing these numbers here somewhere, and that's not what the question is asking you for. So make sure that you always go back and double check to make sure that you're answering it with what the question is actually asking you. So, I want to go from least to greatest. That's another thing that you always want to make sure you pay very close attention to, is that you're starting with least and going to greatest. When you have numbers with exponents, the smaller the exponent, the smaller the number. For instance, if I was talking about the difference between 7, 70, and 700, they all start with a 7. This is equal to 7 times 1. This is equal to 7 times 10. This is equal to 7 times 100. The only difference is we're adding in a place value. Zeros don't mean much unless they're at the back of the number. I'd rather add zeros onto my paycheck every day, as long as there's not a decimal there. So same thing with these exponents. They're talking about a whole place value different. So the difference between a 5 and a 6 in your exponent is the difference between either 5 place values behind it or a 6th place value behind it. So in these two, Boston has an exponent of 7, and the Metro DC area, has an exponent of 5, and the Metro DC area has an exponent of 5. Vegas and Los Angeles both have exponents of 6, so they have a whole other place value inside of them. So I look and compare my exponents first, and then I need to look at their numbers out in front. And since I have them in tens place, I can compare just the 7 and the 9, and I know that 7 is smaller than 9. So the smallest out of these is Boston. So it's going to be first. Then DC is second. Once I'm done with those, I move to my next exponent. After 5, there's 6. Well, Vegas and Los Angeles both have 6, so they're in the same place value realm. Now I just have to compare their front numbers. I have 1.3 and 2.2. Well, 1.3 is smaller, since I'm going from least to greatest, and then Los Angeles. So that's my order. Okay? From there, I must come in and write my answer using the cities, not using these numbers, because the question asked me to order the cities from least to greatest. Least was Boston. Second was DC. Third was Vegas. And last was LA. Let's look at a couple more example problems. Express each number in standard decimal notation form. So they want me to write that in the standard way that you normally see numbers, just written in everyday life. I have 9.931 times 10 to the 5th power. To show your work, just rewrite that first factor. And then I'm going to move my decimal to the right since it's positive, and I'm moving it 5 times. 1, 2, 3, 4, 5. Adding in with zeros as placeholders. So my final answer is 993,100. Number 2 was 6.02 times 10 to the negative 4. I just rewrite that first factor out there, 6.02. My exponent is negative, so that's telling me to move to the left, making it a smaller number. I need to do that 4 times, so I go 1, 2, 3, 4. That's where my new decimal goes. Fill in with zeros. So my answer would be decimal 0.000602. Next, they want us to change from standard to, sorry, this board goes a little bit too far. They want us to go from standard to scientific. It's a lot easier to record numbers this way. all you have to do is come through and find your first number that's not a 0, and it's my 8. Then add my decimal place right there, so I only have one value in the tenths place. Everything else will be added to the decimal behind. I have 7, 8, 5. The rest are all zeros, so I don't have to add them in. If there was another value here, you have to put the zeros that are in between placeholders, but not when they're at the end. We always multiply by 10 when we're doing scientific notation. And if I just came in and placed that decimal right here, I need to get it back to where it belongs. It should be right here is where it belongs. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9 places to get it back where it goes. So my exponent is a 9. Number 4 was 0.524. I need to find the first number that is not a 0 as I come through. It's a 5. I put it right there. So my number now looks like 5.24. I always multiply by a 10. To get it back where it belongs, I need to move it backwards, so my exponent will be negative, and I moved it back one place. Lastly, we're going to look at these table values and put them order from least to greatest. So go in and show that we're going from least to greatest. From least to greatest. So least means I'm looking for the littlest exponents first. I have a 10, a 10, a 6, and a 7. So since 6 is my smallest exponent, it's my smallest number. There was the only 6, so I don't have to compare anything else. Going back, I have a 10, and a 7. So now 7 is my smallest. Going back, I have a 10 and a 10. Since those exponents are the same, then I need to look at the front numbers. And I have 1.22 and 1.12. Well, 12 is smaller than 22, so here we are. And that can put them in order from least to greatest. It says the table lists the total value of music shipments for 4 years. List the years from least to greatest. So these are the numbers that should be listed. So number 1 should be 3. Number 2 should be 4. The next one would be 2. And then the greatest is 1.